We're going to talk about the angle strain in case of cycloalkanes. To understand that, we will first start with the normal alkanes. This is an alkane, propane, with 3 carbons. We can see that there is CH3, CH2, and this is CH3. I don't have the red ones, so I'm using the white ones, but imagine them to all of them to be the hydrogens. So this is CH3, CH2, CH3, which is a simple propane. The bond angle in each of the carbons is sp3 hybridized, so bond angle is 109.5 or 109 degree 28 minutes. Okay, now as we make this as the cyclopropane, what we need to do, we need to make it a cyclic structure like this. Okay, so this is cyclopropane, 3 carbons, 1, 2, 3, CH2, CH2, CH2. This is cyclopropane. So you can see from this, there's a bad overlap of orbitals involved here, which leads to an angle strain. Because earlier, the ideal angle for a tetrahedral carbon is 109 degree 28 minutes. But it has deviated from that to 60 degrees. And this deviation from 109 to 60 degree, this is what leads to the angle strain in case of cyclopropane. Okay, so since we deviated, if you want to see it more clearly, I can use the other models, other type of the models. So this is the simple propane. As soon as you try to make a cyclic, like a bond between the terminal carbons, so what would happen? You can see that there is a curvature there. The orbitals are, or the bond is no longer straight. This is the origin of angle strain. Okay, the other thing which you should look at is that when a cyclopropane ring is formed, these hydrogens, if you look at these hydrogens, all of the hydrogens, they are in the eclipsing conformation, like they are covering each other. If you look from here, this is eclipsing that hydrogen. Sorry, this is eclipsing that hydrogen. This is eclipsing that hydrogen. All hydrogens are in the eclipsing conformation, which leads to torsional strain. So cyclopropane has lots of torsional strain and the angle strain. Angle strain coming because of the deviation from the ideal angle of 109 degree 28 minutes to the 60 degree in an equilateral triangle, and torsional strain because of the eclipsing hydrogens. The strain which comes, that is the torsional strain. So that is why cyclopropane ring is not that much stable. It has lots of energy, so more energy, less stability. It's difficult to synthesize this for long, like it's very much reactive. Okay, thank you.